Hi everyone, in this video I'm going to go through a past paper question from the AQA syllabus. It's from AS paper 1 June 2018 and it was question 8.1. Now this is quite a tricky, involved question on mass spectrometry involving some calculations. So the question says, a sample of bromine was analysed in a time of flight mass spectrometer and found to contain two isotopes, bromine 79 and bromine 81. After electron impact ionization, all the ions were accelerated to the same kinetic energy. So this means when we've calculated the kinetic energy of one, it's the same as the other ion. And then travelled through a flight tube 0.95 meters long. The bromine 79 ions took 6.69 times 10 to the minus 4 seconds to travel through the flight tube. Calculate the mass in kilograms of one ion of bromine 79 and calculate the time taken for bromine 81 ions to travel through the same flight tube. So we have to calculate these two things, but it's a multi-step calculation. We're given a lot of information in the question, and it's worth 5 marks. And we're also given the Avogadro constant, the number of particles in 1 mole of substance. So if you've not done moles yet, a mole is just a chemical amount. We're given an equation to calculate kinetic energy, which we can rearrange. And it tells us the units for mass and velocity. And we're given an equation relating distance and time to velocity as well. Okay, so the first step, we have to use what we're given in the question. So if you're ever wondering where to start, look at what you're given in the question. Look at the equations you're given and see which one can we use. So which equation do we have enough information for? What can we start calculating first? So we can calculate the velocity of the bromine 79 ion. We have the distance of the flight tube and we have the time taken for this ion to travel through the flight tube. So that gives us a velocity in meters per second, and that's our first mark. Step 2, we can calculate the kinetic energy of this ion. Now, the question tells us that the ions were accelerated to the same kinetic energy. So we only need to calculate this once because it's the same energy for both ions. We're going to use the equation we were given, half mv squared. So we do 0.5 or half times by the mass of the bromine 79 ion. So this is the mass in kilograms, so 79 divided by 1,000. Then we have to divide it by Avogadro's constant because we want the mass of one ion. So we always use this constant when we want a mass of a certain number of particles. Then we times that by the velocity that we've just worked out in the first step. And we should come out with 1.32 times 10 to the minus 19, and that is in joules. So we got our first mark here for velocity. We get another mark here for the kinetic energy. And then the question said, calculate the mass in kilograms of bromine 79. We actually get another mark here as well for calculating the mass. So that is that number, 1.31 times 10 to the minus 25. So I'm just going to indicate where the marks are awarded. That one, this one, and this one, and that's in joules. So we've got 3 out of 5 so far. Then, in order to get the time for the bromine 81 ion, first we need a value for the velocity. So we're going to rearrange this equation in terms of velocity. So to get velocity, we do the square root of 2 times the kinetic energy divided by the mass. So we use the kinetic energy we calculated in step 2, because remember it's the same for both ions. We want the mass of a bromine 81 ion. So we do the mass in kilograms, 81 divided by 1,000, then divide that by the Avogadro constant. And our final answer for velocity, after we've square rooted our answer to this, should come out at 1,400 meters per second. Now, if you look, it's slightly lower, this speed for the bromine 81 ions compared to the bromine 79. And if you think about it, that makes sense because heavier ions travel more slowly through the mass spectrometer. So that's an easy way to check if you've got a sensible answer. So that's our 4th mark. And then the final step, finally, how to calculate the time for a bromine 81 ion. We can now rearrange this equation in terms of time. So time is distance over velocity. So distance of the flight tube, which was given to us in the question, divided by the velocity of the bromine 81 ion that we've just worked out. And that gives us 6.8 times 10 to the minus 4 seconds. And that is our final mark.